Yeah. Quadratic inequalities. We've done this, and we've worked these before. Reminder of quadratic equations, which we did yesterday. For the quadratic equation, you've got parabolas. Anytime you have greater than 0, less than 0, equals 0, keep in mind that your 0 is your x-axis. So what you're going to be looking for with these problems, such as x squared plus 6x plus 8 is greater than or equal to 0, you're wanting to know where is your parabola above the x-axis. Makes sense. You could graph it. You could use graphing calculator. Don't really have to, because notice here you got one major thing that's important. This is a positive x squared. It's an upward cut parabola. And you're wanting to know where is that parabola above your x-axis. Well, it'll be on the outside, right? Your parabola is above it here. It's above it here. So your answer, notice it's or equal to. Your answer would be the stuff on the outside. But the problem is we need to know, first off, what these dots are. Where is it equal to 0? So first thing you're going to do is replace that greater than or equal to with equal and solve this. Reminder from yesterday and previous lessons, to solve a quadratic equation, you can either factor, best way is factor a quadratic formula. This one's very factorable. X squared plus 6x plus 8, set factor that formula. XX. Well, there you go. 2 and 4. Set each of those equal to 0, solve them, you get -2 and -4. So this intersection point is -4, this intersection point is -2. Any questions? So therefore, our final answer, where is our parabola greater than or above 0? Everywhere from negative infinity up to -4. Or everywhere from -2 up to infinity. Another one, x squared minus 2x is greater than 8. If you want to, you can solve it as is. What I suggest is move the 8 over and do x squared minus 2x minus 8. Where is that greater than 0? Where's my parabola above the x-axis once again? Positive cut parabola, it's going to be above 0 again on the outsides. Your answer is going to be everywhere from open circle this time, because not greater than or equal to, but greater than. Everywhere on the outside. So again, we need intersection points. Well, that didn't work that out this time. Can anybody take a stab at what they think the intersection points might be? You're close. They'll factor into -4 and 2, so they -2 and +4. Yeah. That's what it's going to factor into. Again, we set it equal to 0 to find out where is it going to actually equal. So this will be a -2 and a +4. So my answer will be, it's going to be above 0 everywhere from negative infinity up to -2, or everywhere from 4 to positive infinity. Yeah, let's do one more of these. Solve 2x squared minus 4x minus 9 is less than 0. Now, since we're dealing with less than 0, again, positive x squared, here's your parabola. Here's your 0 line, that's the x-axis. And we need to know where it crosses. We're doing just less than, not less than or equal to, so again, open circle solution. My parabola is below 0 in the middle, from here over to here. So my solution is going to be the middle region this time. Everywhere from this point A to this point B. So now we've got to figure out what those 2 points are. First attempt, I would try to factor this. 2x squared minus 4x minus 9. Bottoms up factoring, move the 2 to the end, gives me x squared minus 4x minus 18 is a factor. Okay. 6 times 3, 9 times 2, 18 times 4. No, not factoring. So you're going to have to go the other direction with it. You're going to have to take this, use quadratic formula. Always start with b squared minus 4ac to see if it's even feasible, see if it's even necessary to do the quadratic formula. You get a negative here, you can stop. Okay. There's not going to be any intersection points to do that. B squared minus 4 times 2 times negative 9, I believe is negative 72, which is 88. So we're good, we're positive. And that is not a perfect square, so it would not have factored anyway. Then we plug everything in. X equals negative b plus and minus the square root of this jump. Square of 88. Somebody simplify that for me. What are you going to split in the square of 88 into? Explain that. It'll be the square root of 4 times the square root of 22. Everybody good at that? Square root of 4 times the square root of 22 over 2a. I'm going to split this just to where you can see something. I'm going to split this into two separate terms here. 4 divided by 4 would be 1 plus and minus. 2 divided by 4, you can divide numbers, but you cannot divide radicals of numbers. So 2 divided by 4, that's a half. So root 22 over 2. That's your two intercepts. 1 plus root 22 over 2. 1 minus root 22 over 2. So do you see what your axis of symmetry? That's the reason I wanted to do it like that. You see what your axis of symmetry would be, right there, 4. So your solution will be all the values from, if you want to write your solution in exact terms, all the values from 1 minus root 22 over 2 up to 1 plus root 22 over 2. It says if 100 meters of fencing will be used to fence a rectangular region. So we're going to fence in this garden. We're going to use 100 total meters of fencing. What are the dimensions of the rectangle that will maximize the area of your region? We want to fence in with that 100 meters of fencing. We want to fence in as much as possible. A lot of people saying, but if you use the same amount of fence, it'll always be the same size, right? Let me give you some examples. If I use 100 meters of fencing, I could use 10 and 10. That leaves me with 40 and 40, right? How big is this? How many square feet? 400 square feet. Or in this case, 400 square meters. If I use, let's make it a little bit tall. Let's make it 20 here and 20 here. That leaves me with 30 and 30. How big is that? 600 square meters. But do you understand, we use the same amount of fence, but we got more area. So keep that in mind as we're working through this. And also keep this in mind. What's the relationship between length and width? You see that? If we're using, that's the most important part of this problem. If we're using 100 meters of fence, notice how they label it here. They let this be my length, and then they said the width is going to be 50 minus that length. Well, if you use 100 meters all the way around, then half the distance around is going to be 50 meters is what you're going to use. So if this is some value, your other length will be 50 minus that value. Now, why can't we just call it L and W? Why can't we let this be the length, this be the width? Use as few of variables as possible. If you can get by with using only one variable, do it. We're wanting to maximize area. So we have this rectangular garden with a length of L with a width of 50 minus L to find the area of that garden. Let's write as a function. Which, by the way, if you wanted to call it a true function, this would be A of L. L is your input, A is your output. How do you find area of a rectangle? Length times width. There's our area function. And we're wanting to maximize that area function. I'm going to clean it up a step further. I'm going to take that A of L off. I'm just going to call it A, just so we don't get confused. L times 50 is 50L. L times negative L is negative L squared. And I'm going to change it up a little bit more even. I'm going to call it A equals negative L squared plus 50L. Just to where you can see this is a quadratic. Instead of having X and Y's though, this will make it a little bit more real to you. We have L's, as L's increasing, here's what's happening, and we have A's. Instead of x's and y's, we have l's and a's. L's are input, a's are output. We're wanting to maximize area. We want our area to be as large as possible. Look at that graph I just drew. Where does the largest area occur? The vertex. The highest point. That's the reason we went over all that maximum stuff yesterday, is because the highest point on your graph right here, that's going to be the highest A value. That's going to be the biggest A value. And here's a better graph. Let me actually there's the actual graph of that. You have different lengths, you have different areas where they plugged it in, they've actually graphed it, and it gave them what the vertex was. Now let's talk about if we didn't have the graph. Now you can use graphing calculators to do this, right in the handy. Give us further. But again, your maximum area occurs at the vertex. Okay. So we've got to figure out what the vertex of this is. How do you find that? That's in standard form. You've got an A, which is 1. You've got a B, which is 50, or negative 1 and 50. And your C is 0. Do you remember how to find the vertex? The formula, negative B over 2A. If it's in standard form, the x value of your vertex or your axis of symmetry will always occur at negative B over 2A. Negative B over 2 times A, which is 25. That's the input value. That's the length that will yield the maximum area. That's not your area. That's the L that will yield the maximum area. Now, how do I find the actual maximum area? I know it's 6.5, but how do I find that? What do I do with that 25? Yeah, just plug it in. Negative 25 squared, that's going to be negative 625. Plus 50 times 25, that'll be 1250. Add those two together, you get 625. So at an L value at a length of 25, we get an area of 625. Now we really didn't finish answering the questions though, because it doesn't just ask for the length, it asks for the dimensions. If 25 is the length, what would be the width? Do you remember how we defined the length of the width? The length was L, which is what we have. The width was 50 minus L. So if the length is 25, what is the width? So a 25 by 25 squared. And you're going to use all 100 feet of fence, 25, 25, 25, 25. You used all 100 feet of fence, and that yields the maximum area. Something to think about. If you want to maximize the area, and using a rectangle to do it, well, a square always maximizes the area. Yes. There we go. The maximum height of a football. The football is kicked straight up with an initial velocity of 128 feet per second. From a height of 5 feet, then its height above the earth is given by this function, h of t. The height at any time is equal to negative 16 t squared plus 128 t plus 5. Projectile motion. Anytime that something's kicked, fired, whatever, take away all your wind interference and all that, it's going to follow a parabolic path. This tells you the height. Now it doesn't, let me explain something for you. This tells you the height. It tells you how far it is off the ground. This tells you absolutely nothing about your horizontal distance. This is entirely vertical distance. What is your vertical distance at a specific time? If we want to know what is the maximum height reached by the ball, where do we find the maximum height? Here's the ball head here. Okay, over time, the maximum height is right there, vertex. So you're going to have a lot of these problems where you're going to be given this type of situation. You're going to be asked to find what's the maximum height of this projectile. The way that you find that, normally it's x equals, but in this case you have t instead of a. X equals negative b over ta or 2a, or what did you say, 4? Negative b, negative 128 over 2 times a is negative 32, which gives you 4. 4 what? That's t. 4 seconds. Is that what we're asked to find? What is is the maximum height reached by the ball. That tells you when it's going to reach that maximum height. This is your t-axis. After 4 seconds, it's going to be here. That's pretty much, that's your axis if your t equals 4. So how do we find out how high it is? Yeah, h of 4. You just plug it in. Negative 16 times 16 will be negative 256. Plus 128 times 4 is a 512. Yeah, it's 512 plus 5. That'd be 256 plus 5, that'd be 260. Double check it on that, because that's a good high. So maximum height shows 600. Any questions? Cross section of the gutter said has a piece of aluminum that is 10 feet or 10 inches wide and 12 feet long. He plans to form a gutter with a rectangular cross section and an open top on both of his sides. So it kind of shows you a picture. If his aluminum was laid flat, he's going to fold these sides up to form a gutter. What dimensions of the gutter would maximize the amount of water that it can hold? You've got to be careful here because it's got an open top. It changes a lot. So here's what the end. If you look at the end of that gutter, it's going to be a rectangle. And we're wanting to know how much or what shape should he form this into to make it as big of an area as possible, or to make as much water flow through this thing as possible. So pretty much we're asking how much should we fold up? And that's our unknown. And you can see over at the other side, the height of this thing is going to be x. If the height of this cross section, and this is only a cross section, well, let's talk about why am I only concerned about a cross section? If you find the area of a cross section, to find out how much water is in this thing, you would take that area and you multiply by 12. If the area of this is 10 square feet, or excuse me, 10 square inches, whatever. If the area is 10, then you'd multiply by 12 feet, or 120, 144 inches to find the volume. If the area was 12 inches, you'd multiply by the same thing to find the volume. If you can make this cross section as big as possible, it's going to make the whole volume as big as possible. So we're really not concerned about with the whole thing. We're concerned about the cross section. If we fold up x inches, well, it was 10 inches wide before. But if we fold up x on this side and we fold up x on that side, what used to be 10 is now 10 take away the 2 x's that we folded up. That's how wide it is. So now we can find the area. Now we can find how much water is going to fit in this cross section, this one small section of this gutter at any one time. The area of this cross section would equal length times width. 10 minus 2x times x. I'm going to write this x times 5. So area will equal 10x minus 2x squared. That is an upside down parabola. I'm actually going to write the negative 2x squared first. We want to maximize that area. A maximum area, once again, a maximum area occurs at a vertex. This is an upside down parabola, denoting area. As my x values increase, my y value or my area values increase, but then once I hit a certain point, as I keep increasing my x's, my area values start decreasing. So to find the vertex, again, the vertex is located at negative b over 2a, or negative 10 over 4, negative 4, which is 2.5. Now 2.5 is the x. I'm not, let's see, what dimensions, we're not asked for the area here, we're just saying what's the dimensions. So x is fine on this one. You can go a step further and actually find the area of the cross section, but an x value is fine. X is 2.5. That's what I got there. And 10 minus 2 times 2.5, 2 times 2.5 would be 5, 10 minus 5 would be 5. So notice again, this one, since it has an open top, the square doesn't maximize the area. You would fold up 2.5 inches on each side to create a 2.5 inch by 5 inch gutter. Here we go. Next section. Students will use synthetic division or remainder theorem to factor polynomials, and they will combine this knowledge with other theorems to find the zeros of polynomial functions. This is going to be a good chunk of the rest of the chapter. And what we're doing here, we're going to introduce it. We're going to do the first part of it, just to let you know. But what we're doing on these problems, you will use the rest of the chapter. I'm going to go ahead and introduce them so you can start with this section of homework. Use synthetic division to find the quotient and the remainder. We've done this already. Synthetic, now you could use all division, go for it. I don't want to restrict you to just synthetic division, but it's a whole lot easier. If you're using synthetic division to divide by x plus 4, somebody remind me what goes in the box? Negative 4. You set this equal to 0, move the 4 over, whatever you get as an answer, that goes in the box. The coefficients of whatever you're dividing into, just the numbers out front, goes next to the box. 1, negative 14, 5, and negative 9. Oh, thank you very much. I did that to make sure you was playing. X to the 4th, there's no x to the 3rd. So put a 0x to the 3rd. There are negative 14x squared, there are 5x's, and there are negative 9. Anytime that you're missing a term, like I said, anytime you're missing a term, make sure you put in that 0 term. We're missing x to the 3rd. Steps to synthetic division. Whatever number's first, bring it down, and we multiply. I get negative 4. Add the two numbers together. 0 plus negative 4 gives you negative 4. Multiply. We're always multiplying by what's in the box. Add the two numbers together, I get 2. Multiply, I get negative 8. Add the two numbers together, I get negative 3. Multiply, I get 12. Add the two numbers together, I get 3. Keep the last number in the box. Reminder that the last number is a remainder. And then you start counting up. You got remainder, you got x to the 0, x to the 1st, x to the 2nd, and x to the 3rd. So you have 1x to the 3rd, minus 4x to the 2nd, plus 2x, minus 3, plus. Whatever you get as a remainder, put it over what you divided by. The remainder there. There's something special about the remainder when you're dividing using synthetic division. Use the remainder theorem to find p of 3. And what I want to show you here, divide this whole thing by 3, or x minus 3. And I'm going to connect this to show you what the remainder theorem actually states. Divide by, if I'm looking for p of 3, just put a 3 in the blank for now. I'll explain why later. 2, negative 5, 4, negative 6. Go through the process, bring it down, multiply, add, multiply, add, multiply, add. That's your remainder. Let me show you what's special about the remainder. Last chapter we talked about functions. We talked about how to find p of 3. To find p of 3, that means plugging 3 into our function. So that would be 2 times 3 to the 3rd minus 5 times 3 squared plus 4 times 3 minus 6. Which would be 2 times 27 minus 5 times 9 plus 4 times 3 minus 6. Which would be 54 minus 45 plus 12 minus 6. Which is 9 plus 12 is 21 minus 6 is 15. You can use synthetic division to evaluate functions, polynomial functions. To find p of 3, in this case, instead of going through all this plugging in stuff, you could have simply used synthetic division. Whatever number you're wanting to plug in, put in the box. Whatever you get as a remainder is what value you would have gotten if you had plugged that in.